All right. So now I'm going to talk a little bit about end behaviors for both the exponential function and the natural log function. All these also hold true for if the bases are not e for both of these functions. So if you had base b to the x power, it would still hold true that you would have these end behaviors. If you had log base b of x, it would still hold true that you would have these end behaviors as well that are stated for the ln of x function. So for limit as x goes to infinity of e to the x, this ends up going out to infinity. You can think of it as 2.718 to some power. And then if you're going to increase it, increase that power by 1, you're making that value that you had before 2.718 times larger. And so as x keeps increasing, the value of e to the x keeps increasing. And it heads out to infinity because of that. With ln, or with the limit as x goes to negative infinity of e to the x, that equals 0. This is converse to what we were saying before, where if you had e to some power and you brought that power down 1, then you would be dividing it by 2.718. So that value of e would be creating or dividing by that value of e, or reducing the exponent of that value of that exponential by 1 would cause the overall value to decrease by a multiple of around 3, but that e value specifically. And so you would continue to decrease and decrease and decrease this function, but you would never go past 0. You would never flip to a negative sign. The sign always stays the same with e to the x functions or the exponential functions. And so we would end up with a value that continues to get smaller but never crosses 0. And so it would end up approaching 0 overall. If we look at the limit as x approaches 0 from the positive side of ln of x, we're going to be looking at very, very small magnitude values, which are positive, being plugged into this ln of x function. Now, if you were plugging in very, very small magnitude values into ln of x, you would be getting values that would need a very large negative number in the exponent for the base e in order to reach those values. And as they continue to get smaller, that exponential or that exponent would have to get even larger to accommodate that. And so the value of ln of x tends towards negative infinity as x tends towards the 0 value from the positive side. And the domain for ln of x is going from 0 to infinity. You can't plug in negative numbers. So this is as far as we can go as we're headed in the negative direction for any point on ln of x. So you can only get to that 0 value from the positive side with this function, and that reaches that negative infinity value. If we're going the other direction with ln of x, and we're going from x to infinity, the value of ln of x actually is unbounded. There is no upper bound to the value that can come out of ln of x. And part of the reason why that is because there's no reason you would bound the exponent in the exponential function. You can plug anything in for the exponential function and get anything out. It may explode to an insanely large number or an unfathomably large number, but the exponent is unbounded in terms of what the domain is for that function. And so the range of the ln of x function is unbounded in terms of how large of a value you could plug into it and get something out of. And so that is sort of why you're able to take that exponential value and relate it to the ln of x value, where if you're plugging in a particular number that you want that you can get out of e to the x, then you can get that correspondingly large ln of x value out of it. or x value from the ln of x value. And so as you tend towards infinity with x, the limit as of ln of x tends towards infinity as well. And so we've got that, and it's, again, this is true for other bases, so it doesn't need to be ln of x. It could be log base 2 of x, log base 10 of x. The e to the x could also be 2 to the x, or it could be pi to the x, could be 10 to the x. All of those work or have the same end behaviors as these cases. So, all right, that's the end for 11.2. I hope that you guys enjoyed this video. I'll go ahead and get the next one set up for you guys. All right, talk to you soon.